video, I'm going to show you how to use the graphing calculator to solve many things with quadratics. So the example we're going to look at is, at a Civil War reenactment, a cannonball is fired into the air with an initial velocity of 128 feet per second. The release point is 6 feet above the ground. The function h equals negative 16t squared plus 128t plus 6 represents the height h in feet of the cannonball after t seconds. Question A wants us to find the height of the cannonball after 1.5 seconds. So if we were to do this without the graphing calculator, we could just substitute 1.5 for t because we're looking for h, so we want to find h, so we wouldn't put anything there. And it's 1.5 seconds. Seconds are a measurement of time, so we would put 1.5 in for t. Now, with the graphing calculator, though, it can do that for us. So we start by going to y equals, and once we're in y equals, we type in the equation we're given. Now, the equation we're given has t's, but we'll use x's instead. So negative 16 x squared plus 128x plus 6. Now, when we hit graph, we can look at our picture, and it's coming very slowly. Okay, so we see it coming up over here and back down over here. Because these two are very, very wide, it means that our vertex is going to be way, way up. So we're going to change our window to try to see the whole parabola. So we press window, and from here, I'm only going to change my y max for right now. And when in doubt, I like to change my y max to something really big because then it's easier to move it down instead of keep trying to make it bigger and bigger. So I'm going to start with 500. I don't think a cannonball can go 500 feet in the air, so we'll hope that's enough. There it is. Good. So we can see where we start, where we stop, and now if we want, we can tighten down the picture a little bit. So if we look over here, I really don't need anything in the negatives because I can't have negative time. So I can change my window, make my x start at -1, and we can chop down the y just a little bit to, I think, 400. Will give us a little bit better picture. So we hit graph again, and now we have a little bit better picture. So here's our parabola. Now, we want to find the height of the cannonball after 1.5 seconds. There's two ways to do this in the graphing calculator. The first is to do second trace, and we're going to choose option 1 for value. And then it tells us x equals. Well, we say, okay, well, I want x to be 1.5, so we press 1.5, hit enter, and it tells us right here that y is 162. So, find the height of the cannonball after 1.5 seconds. So the height of the cannonball after 1.5 seconds is 162 feet. Okay, so the other way to do this is we could do second graph. Now, second graph gives us a table of values. Right now, you'll notice that there isn't really much in my table, and that's because because of the way I have the table set up. So second table set, right now my independent is on ask. So what that does is it allows me to type in anything I want. So I can go to second table, type in 1.5, hit enter, and I get 162 again. So this is another way to do it. And this way is particularly helpful if you need a lot of values. If you just need one, getting it from the picture is fine. But if you need a lot, once you're here, you can just keep hitting them. I want 2, I want 5, I want 8, I want 9, I want 100. Well, 9 and 100 are silly because they're negative answers. So at that point, the cannonball's already hit the ground. But that's how you can find a lot of different things. So our next question says, how long after the cannonball is fired is its height 150 feet? We go to y equals, and we leave our original equation in y1, and in y2, now we're looking for height. So height is the y. So what we're going to do is we're going to type 150 in for y2. Once we've done this, we're going to press graph, and now we have a horizontal line where y is 150. We'll notice that the cannonball is going to reach 150 feet twice, once on the way up, once on the way down. So we can find them both. Second trace, option 5 for intersect. Now, the first time we can just hit the cursor 3 times, or I'm sorry, hit enter 3 times, enter, 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 and it tells us that the first time it happens is at 6.6457 seconds. So we can say that the first answer is 6.6 seconds. Okay. Now, the second one, it's going to take a little bit more work. So we're going to have to do second trace, intersect again, but this time we have to move the cursor over to the other intersection. Otherwise, the calculator is just going to keep finding us the same intersection over and over and over. So we move the calculator over, close enough, enter, 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 and it tells us that this one happens at 1.354 blah 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 seconds. So our second answer is we can round that to 1.4 seconds. Okay, so the cannonball hits a height of 150 feet twice, 1.6 seconds and 1.4 seconds. How long after it is fired does the cannonball hit the ground? Well, this is a good question because a lot of times we need to know how long it takes something to hit the ground. In order to figure this out, we have to think about what the question's asking. How long? So the question is asking for a time, so that means that we're looking for t. So that means we have to substitute something in for h. So how long after it is fired does the cannonball hit the ground? So we have to think, what would I put in for h? Well, if I'm on the ground, my height is 0. So we go back to y equals, and so we'll change the 150 to 0. I'll just type in lots of zeros so I don't have to clear it. And then I'll hit graph again. So here's my cannonball. Here comes my 0. So we'll just do second trace again. Second trace, intersect, make sure the cursor's over closer to the one that we want. Probably close enough. Enter, enter, enter. And we get 8.04 seconds. So we can round that and say that it would be 8 seconds. Okay. So our next question, what is the maximum height of the ball, and how long after it is fired does the cannonball reach its maximum height? If we were doing this by hand, we would actually have to do E before D. Now, we have to do E before D, but a lot of times it's asked in this order, so that's why we're practicing with it in this order. The reason we have to do that is the maximum height happens at the vertex. In order to find the height at the vertex, we first need to know the time that it happens. So we find the time that it happens, if we're doing this by hand, by finding the axis of symmetry. The vertex always occurs on the axis of symmetry. So if we were doing this by hand, we would do x equals negative b over 2a, find x, then substitute that back in to find the maximum height. Because we're doing this with the graphing calculator though, we do second trace. Now we want the maximum, so that's option 4. Now, finding the maximum and minimum is different than finding the intersection. We don't just hit enter 3 times. If you notice right here, it says left bound. So that means we have to go to the left of the highest point. To the left, to the left, to the left. Keep moving. To the left, to the left, to the left. To the left, to the left, to the left. Left, 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 left. Okay, now I'm clearly to the left of the highest point. So I'm going to press enter. Now you'll notice it says right bound, so I have to go to the right. So I'm going to go to the right, go to the right, go to the right, to the right, to the right, to the right, to the right. Okay, so now I'm clearly to the right of the highest point, so I press enter. Now you'll notice my calculator gave me these 2 dashed lines. So what the calculator is going to do is it's going to find the highest point between these 2 dashed lines. So it wants a guess, you don't really have to guess. Just press enter. And it tells me the maximum is 3.99986, so we can say 4. And it happens at so the maximum happens at 3.99, pretty much 4 seconds. And the maximum height is 262 feet. So now we can actually answer both questions at once. What is the maximum height? 262 feet. And how long after it is fired does the cannonball reach its maximum height? Well, that is our 4 seconds. So in the graphing calculator, finding all these things about the parabola is really quite simple. It's not that difficult to do it by hand because we would either use the quadratic formula when we're solving for t. We set our equation equal to 0, solve using the quadratic formula or by factoring. When we're looking for the maximum, we find the axis of symmetry and then we substitute that back in to find the highest point. So either way, it's fine, but with the graphing calculator, it's so much faster.